let's write this down. We got parentheses 3x to the negative second, y to the second, and let's cube all of this action. All right. So once again, that's 3, x to the negative second, y to the second, and everything's cubed. OK, so according to PEMDAS, what do we always do first? We always do parentheses first. So let's take a look in these parentheses. And what can I do within these parentheses? That's not true. There is some movement that can happen. Sir?
You can move x like downstairs.
I can move x downstairs. That's right. So we can rewrite, because it's a negative exponent, so I can rewrite it as 1 over x to the second. So the way I rewrite that now is I have 3 stays up top, y squared stays up top, and on the bottom I've got, you just said it?
X to the second.
X squared, that's right, x to the second. And the whole thing is still what?
Parentheses.
Is cubed within parentheses. That's correct. Are we doing all right? So take me further. Take me further. What happens now? Yes?
Distribute.
I distribute, and give me a little more?
Like distribute the 3 and to the 3 and the y cubed. I mean squared.
Yes, to the 3 and the y squared. People forget that sometimes, that it also goes to the 3. But keep it going. I cut you off.
Cube the, or do it to the x too. The x squared.
Yep, yeah, cube the x squared as well. All right, I'll give you a second. And by a second, I mean like maybe 8 seconds. Cool. So what do we get? What do we get here? So 3 cubed would give me what?
27.
So we have 27. What about the y?
Y to the sixth.
Y to the 6th. That's right. Because remember, there are 3 2s. So it's 2 times 3 gives us 6. And then down below, we got
Y to the x.
x to the 6th. And this is my answer. Good for that? Yeah? OK, cool. Let's do another one. Let's say I had 4 x to the negative second. Again, y to the 4th over 8x y to the 6th. No parentheses. No parentheses. Thank you for the question. We just want to simplify this. We want to simplify this. All right, talk to me.
You can move x to the negative squared down and make the squared positive.
OK, either I can go ahead and I can take this and I can move it down, or I can do the subtraction method thing. I can do either of those. Which are you more comfortable with? Can you give me feedback? Subtraction method. Some of you moving it down. OK, so let's just show subtraction method real quick. Remember, that's going to be x to the negative second minus what number? 1, because there's like a 1 right here. OK, so minus 1, which would give us x to the negative third. And to make that positive, we've got to drop it to the bottom, right? OK, so down here, we have x cubed. All right, so we've taken care of these so far. What else now? All right, we started from the bottom here. Yes?
You could take subtract 6 from 4y.
OK, so we have y to the 4th minus y to the 4th minus 6, which gives us y to the negative second. So where does it go?
On the bottom.
On the bottom, y to the second, positive second. Because as soon as you move down to the denominator, it is a positive exponent. Now I've got 4 over 8. What do I do with that?
4 on the top, 8 on the bottom.
I can do that. I can go ahead and say 4 on the top, 8 on the bottom. Well, what's something else I can consider? Yeah?
You can simplify it down to 1/2.
I can simplify it down to 1/2. So let me pop that back. Blah, blah. Oh, look. 1/2. OK. Is everybody cool with that? The 4 8s gets me down to 1/2? Good, 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 good. All right, so I want you to always be doing that. I want you to be looking for that. How can I simplify this further? How can I get it down further? All right. So. Let's do one more. Let's look at, like, let's say if I have 2x to the negative. Let's go negative third. Live the dream. And then we have y to the 5th over negative 4x squared y to the, let's go third. All right? All right, so if we played the PEMDAS game, what do we usually do first? Parentheses. So PEMDAS starts with a parentheses. Okay? So can't do much with the parentheses because it's just 2x. All right, so let's go to exponents.
Distribute.
All right, so we distribute that in. Now, we end up with like a negative third and a negative third there? Is everybody okay with that? Now what do I do with those? What do I do with those? Yeah.
You move them to the bottom.
Okay. I can go ahead and I can move them to the bottom. So he's going to come down here. So I'm going to have a kind of like a big denominator happening. So I've got 2 to the what? 2 to the positive third.
X
X to the
And I got an x to the positive third. All right. And that's multiplying times a negative 4. And then I got an x to the
squared.
yeah, I've got x to the second, or x squared, and a y to the third, and up to the top I've got y to the fifth. Wow, that looks messy. So, what are we going to do about that?
Subtract 3.
Subtract 3.
Like on the y.
So you handle the y's. Okay, so you want to go ahead and take care of the y's. So we have this action, all right, and this weird kidney thing happening. So y to the fifth minus y to the third. Not really minus, divided by, so you're subtracting. So you get y to the
second.
Now where does y to the second go?
On top.
Up top, so we're like, boom. All right, now down below, what are we doing? Sir?
You can combine the two x's to make x to the 5th.
That's right, so I got x to the third, x to the second. They're multiplying. When we multiply, we add the exponents, so we get x to the 5th. Okay? Anything else? Yes, ma'am?
You can do 2 cubed, which is 8.
2 cubed becomes 8, that's correct. I want to share it out a little more. Somebody else. What else? So I've taken care of this, I've taken care of this, I've taken care of this. What do I got left? I got negative 4 and
multiply the negative 4 and the 8.
negative 4 and the 8. I gotta handle my business. All right, so 4 times 8, or I should say 4 times negative 8. I apologize.
Negative 32.
Okay, so we're at negative 32. So all this with our beautiful Christmas colors. All right, we're at y squared over, or we could say negative. Oh, I didn't leave myself much space. I don't like that. All right, so I'm leaving myself with negative of y squared over 32x to the 5th. Are you okay with the fact that this negative kind of came to the center here? Is that all right?
Mm-hmm.
Yes? Yeehaw? Okay. Yeah, so when you have a base, so this is a base, is everybody okay with that? And the exponent is 0, the answer is basically always 1. And I shouldn't say always, because I'm about to show you a counterexample to that. But for the most part, it's always 1. So let me show you an example of this, which I showed in a previous video that we saw the other day in class. All right, but that was, for example, if I had 7 to the 5th over 7 to the 5th. Now, whenever you have the same numerator and denominator, what's your answer? 1. Is everybody okay with that? Because it divides itself out and it goes into itself once. Well, in this case, if I wrote it as 7 to the 5th minus 5th, you would end up with 7 to the 0. And that way, we had already stated that this is 1. Well, 7 to the 0 is equal to 1. Is this all right? Okay. The counterexample. You can't have an example of, like, let's say 0 to the 0. Okay? Because in that case, like, you can't have 0 to the 5th. Actually, you just really can't do this at all. Now, why can't you do this?
Because it's nothing.
0 is
Zero.
nothing.
Multiplying.
0 multiplied by 0 is nothing, but give me something. Tell me what's happening here.
Well, 0 times 0 times 0.
Get you a whole mess of zeros, yeah?
You're dividing by 0.
You're dividing by 0, because remember, fractions are division. Is everybody cool for that? And can we divide by 0? No, okay, it actually might even set this video on fire because of the fact that I've shown it that. Okay, so you can't divide by 0. That's like the law. What do we call it when you're trying to divide by 0? It is, say it again?
Undefined.
Undefined, that's correct. So this would be undefined. This would be like math fail. It would just be undefined. Are you okay with that? So this is the example in which you can, where something to the 0 power is not 1. Everybody all right with that? Now if I did have negative 5 to the 0 power, that does still equal a positive 1. This does still equal 1. Okay?